So here is another the viewpoint to help how to. Here is more practical. So say we have the practical system like this, and we've seen this before. And in terms of our modeling, this is our output signal. In terms of the voltage, this is our input voltage. And for this one, I think if you remember that is, we've done this one before. So here the output can be related to using this loop. The output voltage can be this. If we use this loop, the input can be related to this one. Okay, now if we have these systems, and how can we draw the block diagram? The way is this. First one, we take the Laplace transfer on this system. So again, I'd like to work on this one. The first one, you take the Laplace in the transform. This one will be equal to R EI minus EO. Okay. So with this one ready, then you can see this is our output here. Output equal to 1 over R multiplied with the difference. So then we put the difference here. So this block represents these equations. Okay? Very straightforward. Then the second one, we take the Laplace inverse of this. Sorry, taking the Laplace transform of this one. So again, this is constant C. And for the integral, integral basically, this one, the plus becomes is I s divided by S. Okay. So this one, integral after the Laplace is 1 over S. So basically this is IS and divided by S. Okay. So now this one, EO equal to CS, let me rearrange CS over I. And this is, sorry, I here. So EO equal to this, EO equal to here, we put it here. Maybe we can put the, say, CS, and here is our I. Okay. So here is the thinking. Here I added up according to this information. But since this block diagram, the authors choose to go here. So the authors try to choose go here. So EO and C over S, either way. Okay. So once we have this one, simply this is the signal from output. We simply link it and close it. So that is a way, kind of the opposite way. And if we have the system, then if you like to build up the block diagram, this could be the one example you can for your reference. Okay. The next one, here is the exercise here. So I think here should be very straightforward, and let me do this one more time with you. So if we have an original block diagram like this, probably you can try it starting from, always start from the output C will be equal to the operation of the two signals here. So this plus this one, let me do this one first. This one will be equal to from here, so that one will be H1 over G times this one, and that one basically equal to, jeez, what is this? Oh yeah. this. This is very bothersome. Let me do this one here. This is a big note here. Okay, this is a big note. That will do. That will help me. And then let me define an intermediate state. Say, let me call this as x here. Okay, that'll be easier. Pretty much will be easier for us. So from here, c equal to x plus h1 g times x. So let me rearrange. So 1 plus h over g 1 times x. Okay. And then what is x? The x x equal to g times this one. That one is equal to r minus h2 times x. Right? So I will try to solve for x first and plug in here. So from here, the this one gr minus gh2x. So therefore, x will be equal to gr 1 plus gh2 here. Okay, so let me continue here. So here will be equal to 1 plus h1g g plus h1. And now I introduce x here, so that is g1 plus gh2 times r. So from here we can do the calculation. That will be g plus h1, 1 plus gh2r. That's it. And that is this equation here. Okay. Here, since for some reason I show you another tip. If you would like me, you can define any intermediate, we call the variables or intermediate states, and hopefully that can help you. But eventually you will try to replace that one with all the given information. But sometimes this will be useful here. So that's the one exercise for you. Yeah, I see some of you kind of keep writing. If my speed is too fast, tell me. I can slow down to wait for your writing. But the best way is here. Those slides are available on Blackboard. So for sure, next time Wednesday we're going to talk about signal flow graph, and that one hopefully you can print and then bring with you. That can save a little bit time. Okay. So. So I think the remaining will be the exercise. So let me go over this quickly. Then if you need time to catch up, we can go back later after our class. So here So here are the examples here, and providing for you. And this one, even I have the answers provided here, okay? And even this one, here we have the different approaches, we have different examples. And textbook, in our textbook, it provides us quite a bit examples. And those ones are kind of step by step. And the approach the authors use might be different from what we've been exercising, following my thinking, but you might have your thinking process. That's okay. There's a no unique way to develop the process. But as long as you make sure the calculation or the algebraic equation is right, then you should get the right answers. Okay. And then look at the next page here. And this one is very complicated. And for this one, I never use the MATLAB command to solve this one. I always use my hand, and because I know what I'm doing, that is the final answer here. Okay, providing to you, and that won't be on the test. We talk about the practical issues in terms of the And here is the textbook example that it's too long, so I kind of put in this way. But this could be the good exercise project for yourself. Okay. And yeah, another example here. So basically today I'm using 1 lecture hour to finish the block diagrams. And here I have introduced you the certain basic components and then how to operate the information. So I think that should be sufficient. So the remaining will be up to you how to polish your skills doing the examples. So Wednesday I will do this signal flow graph, and that is kind of important and a little bit complicated issues. So you can print out the handout, bring with you. Okay, thank you.